Again, reminder, we are taking TSI on the 18th and 19th. Look at your day 2 notes. Get your day 2 notes, and we labeled them at the top. We labeled day 2 and day 1 so that it would be easy for us to refer back to them. And then on these notes, I labeled it day 3, but if you want to write day 3 at the top, you can do that too. So look at your day 2 notes. At the day 2 notes, we learned about 2 new logarithms. So here is the first one. The first new logarithm. What do we call this? Common log. Very good. We call that a common log. If you weren't able to look at that and identify that that is a common log, then you need to go look at your day 2 notes and you need to highlight that word common log. What is the base for a common log? 10. Yep. Go back and highlight that from your day 2 notes. We need to remember that. You need to know that. ln of x, what does that represent? Natural log. A natural log. So if you didn't know that, you go back and you should highlight that on your day 2 notes. What is the base for a natural log? What? E. And remember, what does E stand for? The weird name, right? What is it? Okay, it looks like we would say it Euler, but it's spelled like oil, like an oil field. We need oil to fry our chicken. It sounds like Euler. That's what it sounds like. So if you want to write that on there, it sounds like Euler. So that's the E. And where is that little E symbol button on the calculator? Do y'all remember? Yeah, it goes with division. It's on the division button. And so E is a number. It's an actual value. It's like pi, 2.718, blah, blah, blah. I'm pretty sure. Okay, moving on. So we need to get our day 1 notes out now. So find your day 1 notes. It should say day 1 at the top. So we are going to be finding solutions with graphs, but we have to know what we're looking for. And so the solution, do y'all remember other words for solution? Do I have what? It's would be over here. It's 7.1 and 7.3. It's x-intercept. What we're finding is x equals, and it's where it crosses the what axis? Yeah, x. The first part of these questions tell you to draw an asymptote. Well, It's an asymptote for an exponential. It's an asymptote for an exponential. So go look on your day one notes, the exponential graph that we made, that one was the one on the left. On that graph, what kind of asymptote was it? Was it horizontal? Was it vertical? What did it look like? For the exponential graph, so this is the one that's on the left. So the asymptote is going to be like that, and it is horizontal. Okay, for every time when we have an exponential graph, that asymptote will be horizontal. So do you see the two graphs that are given? Imagine where those asymptotes would be. Do you see like where the natural spot for them to be is? They're at different spots for both of them. They're at a different spot. So remember that an asymptote, your graph can't cross an asymptote. So that's important to know. Your graph can't cross the asymptote. So for the first one, if I go put that asymptote right here at 0, I'm going to cross the graph. That is not okay. So do y'all remember on that day one notes, I made you write down off to the side what part of the equation tells you where that asymptote is going to go? We wrote it down on our day one notes. Yeah. So look at that first equation. Where should the asymptote go? It needs to go down at -4 because of that. So I'm going to go put my asymptote down here. Does that make sense? Okay, the equation moved it down. The asymptote is not the answer. The question asks you to find a solution. So the solution. The solution is where the graph crosses what? X-axis. So for this problem, where does the graph cross the x-axis? Where? Right there. That is your answer. For the next graph, is it shifted up or down at all? It's like +0 at the end. There's no number at the end. So my asymptote is going to be at 0. So where does my graph cross the x-axis? Never, because it's never going to cross that asymptote. So there's no solution. I'm going to pause for like 2 minutes. Go look at the first few questions on your homework. Because the answer, the solution, is where your graph crosses x. My graph crosses x there. Well, this one, there's an asymptote at 0, so where's it going to cross? Never. Right, never. It can't cross. And so I want you to go and look at your homework. See if you can sketch on that asymptote. See if you can find where the graph crosses x. Sure. We haven't drawn on the asymptotes for the log graphs yet, but you could still say where the x is without even us doing that part yet. All right, you should have just made a dent in the front page of your homework. Remember, that's something we don't want to slack on. At the end of the year, we're not going to want to do anything. So we got to get it all done right now. We got to do as much as we can right now at the beginning. On to the second part. It's like the same thing. It's just with logarithm graphs. So look on your day one notes. She already knows what I'm going to ask. Those asymptotes for a log graph, those are up and down every time, and that is vertical. Vertical. And another thing, your graph can't cross. Can't cross the asymptote. The solution, that's where it crosses the x-axis. So it's x equals, it'll be x equals. So before you look up, I want you to sketch on your graph, see if you can figure out where the graph should have its asymptote. We also wrote down on our day one notes, I made you draw an arrow. So for the exponentials, it's what k is. For the logarithms, it's what h does. Do y'all agree? Does that feel right? Where we put them? Where I put them? Okay, that first one. The asymptote is because it's -2, but remember, everything that's with the x grouping moves opposite. Okay, so it moves my graph +2. And then for this one, there is nothing with the x. So that's the same thing as like x plus 0. So it's at 0. So we draw on our asymptote, easy peasy. But that's not the question. That's not what we're trying to find. We're trying to find the solution. Where does your graph cross the x-axis? You should go put a point on the graph where you think it's crossing the x-axis. They both look like they cross to me. So we just identify that solution. So for the first one, x is equal to what? 3. For the second one, x is equal to what? Those are easy. So I'm going to give you another 60 seconds, 1 more minute to see. You might even be able to finish that entire front page. That's it. The solution to any graph is where it crosses the x-axis. There's also a couple fill in the blanks on the homework. Make sure that you fill those in. Which problem? So for number 6 on the homework, it's like, yes, plus 0.
Is it 0 too? Like for this, so Gabby's saying it's 0, but then the 1.
So for that one, for the answer,
No, for the
where the asymptote goes. So it has to go over at 1. It can't be at 0 because you cut through the graph, right? All right, we just did the whole front page of our notes. Easy, right? We're good at this. Down. That word and that word. The first 2 blanks on the homework, the things we're plugging in are horizontal or vertical. And then the other one, that's from our day 1 notes. It's the very first blank on our notes from day 1. Yeah, day 1. Very first blank. Exponentials and logarithmic functions, they are what? Inverses. Inverses. Y'all are doing so awesome today. All right. I found this oddly satisfying video. It's kind of weird, I'll be honest. You've seen these? We've seen these?
No.
He's seen these. Hold on. Is there any work? Let me turn my volume up. I don't, maybe there, okay. I feel like this took a long time. I don't usually have salad for breakfast, but. What do you think that is? Garlic? Oh, it's browning. Oh. Well, oh. Like when you put something If you put garlic in a pan, it's gonna turn brown. Oh, that's weird. I guess it is coffee. But browning is where it kind of turns a little darker. Have I ever done that before? I've never seen that before. Oh my goodness. I thought you were gonna make like an omelet. Cooking some garlic. Your toast is ready? Ooh. That's funny. It's called My Jam. Uh, that's a kind of a bizarre breakfast. Do you see his little cat friends? You see these little cat friends right here? That was bizarre. I didn't watch it all the way through. I just saw the beginning and I was like, oh, okay, that might be interesting. Oh, we've got a fried pork chop. I don't really know. All right. You what? The fried pork chop? Or really any of it? Yeah. That was interesting. I can only imagine how long it took to make that 3-minute video. That would have taken forever. All right, on to the back. On the back, we're going to learn about the property of equality. The property of equality. What word is inside equality? Equal. So things are going to be equal. So this sounds a little mathy and confusing, or like maybe even it seems really simple and like, duh. But it says, let B be bigger than 0. Okay, so a number bigger than 0 could be 4. All right. Let B be a number bigger than 0, but it can't be equal to 1. So this is an exponential. We know it's an exponential because when you have exponentials, the variable is up as an exponent. So it says, let B to the X equal B to the Y. And this is true if and only if. So what is the only way that this side can be equal to this side? If the bases are the same, then what do we know about these exponents then? Yes, the property of equality. Then X is equal to Y. So the exponents are equal to each other. So we know that if the base is the same, if the base is the same, then we can set the exponents equal to each other. So this is like a little example right here. Are the bases the same? Yeah, they're both 3. So if the bases are the same, here's what happens. We're left with just the exponent. That's it. So for question number 5, are the bases the same? Yeah, whenever the bases are the same, you can mark them out and you're left with the exponents. Can we solve for x? Yes, of course we can. So to get x by itself, what should I do first? I need to move the 5, so I will add 5. And I just have one last step. Divide by 3. What does x equal? Y'all just did some big kid math. So for the second one, are the bases equal? No, but we can do some math magic because I'm working with 9 and 3. How could I make the bases equal? I could rewrite 9. And if you have your exponent chart out, that can be helpful. So I can rewrite 9. So how can I rewrite 9 so that is a base of 3? 3 squared. But there was already a 4 there. So we have to multiply those two things together. If there was something already there, you have to multiply it. 4 times 2 is 8. I don't know what 3 to the 8th power is, so y'all are going to have to look on your exponent chart. Oh, I'm sorry. We don't have to know what 3 to the 8th power is because what do? The bases are the same. Uh-huh. Uh-huh. Bam. Sure. Doesn't matter. Either way. The next problem, what do? Yeah, so which one are we going to rewrite? The 4. So I'm going to still have 2 to the 5x power. And then I'm going to have 4 to the 2nd power. And then there was already stuff there. I'm going to leave it there. They have to multiply. So the 2 has to multiply everything that was already there. Oh, why did I put a 4? I don't know. There we go. Now, are my bases the same? Yeah, so what do? And I'm left with the exponents. And you know what I'm going to do as I rewrite the second one? I'm going to go ahead and distribute this in. So I get 2 times 2 is 4x, and 2 times -1 is -2. So I'm going to go ahead and distribute as I rewrite it. So now I have variables on both sides. Anytime that you have variables on both sides, which happens a lot on the homework, I mean, you'll have variables on both sides. To decide which of the equal sign you want to put the X's on, look for the bigger X. So I have 5 and I have a 4. 5 is bigger. So let's move towards the 5. It's like a magnet. So move towards the bigger X. So if you need to write that down, that's a good idea. Move towards the bigger X. That's what we're going to do every time. So that's what I'm doing here. I'm going to move towards the bigger X. That will keep you from ending up with a negative X most of the time. So 5 minus 4 is 1. Do I need to do anything else? Okay, so if I move the 1 over, what is negative 2 divided by 1? It's just the same. It's the same. How do you feel so far? We just need practice. It's simple. It's just we're a little bit rusty with our algebra skills because we learned algebra through COVID. So we don't have a strong algebra 1 foundation. So just solving equations, sometimes we still struggle with a little bit. So what I'm going to do is I'm going to give you guys a few minutes to go look on your homework, find any of the problems that are on the back that are the exponentials. They don't have a log. You got 2 flavors of problems on the back. They either have a log or they don't. The ones that don't, those are an exponential. Uh-huh. So on the back, you've got, I believe, 6 problems that are exponentials. So go see how many of them you can do. I'll give you 5 minutes. Go see how many of those on the back that you can do. Sometimes you have to do that, yeah. Mhm. That's fine. Mhm. I believe you, I believe you get a fraction answer. If it's negative, then when you move it, it's positive. But if it is negative, I mean, you can leave it there. If you've only got one X, you can leave it there. If you only have one X, you can leave it there. Yes, you get a fraction answer.
It's one.
You want to move that 4 away from the X. Alrighty, we are almost done with our notes. All we need to do is learn how to figure out how to solve them when we're working with a log. So the property of, what do you think goes in the blank? Look at the top of the page. What do you think goes in the blank? Equality. What word do you think of when you see equality? Equal, probably stuff is going to be equal. So this says, if B is a positive number other than 1, so B can be any number, just not 1, and it needs to be positive, then log base B of X is equal to log base B of Y, if and only if, so these things can be equal to each other only if what two things are also equal? X and Y. So let's look at our example. So if, do we have like bases? They're both a 5. So if you have log equals log, nothing else, then we do the same thing. So we're left with X equals 8. So if the bases are the same, okay, if the bases are the same, you can cancel out the log and you're just left with the stuff. For question 8, are the bases the same? So let's mark off the log part and we can set the stuff equal. How can I get X by itself? Yep, divide by 3. What's 30 divided by 3? 10. The confusing part with these is that you can't have anything else. It has to be just 1 log equals just 1 log. It can't be this plus 4. You can't cancel it out. Like it has to just be log equals log. Okay, for the next one, do I have 2 logs with like bases? And what is the base for that one? I don't see it. 10. All right, I have an X on both sides of this equation. Which one is my magnet? 2X. So I moved the 8 to the other side as well. Now I'm left with 3x is equal to -3. One last. I don't know. Jeez. There we go. Much better. So now what do I do? You're done. The next problem. What kind of log is that? Natural log. And so you got natural log equals natural log. They're the same. So we set the stuff equal. And we solve for x. I'm subtracting 5, so I need to add 5. I'm subtracting, so I would move it over by adding it. I get 10. Do what? Then you can't. Then you cannot use the property of equality. Do you see any on your homework like that? Then you don't have to worry about it. All right, that is it for today's notes. So you can go and do your homework.